Okay, everybody, our second type of reaction are our decomposition reactions. So what does it mean to decompose? That means to break down. Okay, so you're breaking down a single compound into two or more elements. All right, so be careful because when you break them down, sometimes you're going to break them down and it's one of the diatomic elements. So you have to write down that Br2, I2, N2, Cl2, H2, O2, or F2, okay, for your Brinkelhoff. Okay, now since these compounds exist naturally in nature, okay, they need some sort of energy in order to break them apart. So like heat or light or electricity, like when I show you the electrolysis, that is going to catalyze or break these things apart. That's why medicine bottles, like if you have a prescription, they're in that special like orangey plastic, and that's going to be to filter out the UV rays, which are going to possibly break it all down. So in general, you have AB yields A plus B. So this is the divorce relationship. So if A plus B yields AB, all right, then guess what? That is the marriage. So they are opposites. Yeah, our decomposition and our synthesis reactions are going to be opposite of one another. And a lot of the same things kind of follow each other. Okay, so if you have H2O, that is your water, and it is going to undergo electricity or electrolysis, so you might see the little heartbeat EKG symbol. You're going to break up the H2O into H and into O. Recognize that they are both diatomic, so you have H2 and O2, and then balance. Okay, easy enough. HGO. Oh, I wish I could have some mercury oxide for you guys and heat it up, but mercury is a little bit toxic, so it's not going to be okay. It is this white solid, and when it breaks up, it gives you a silver liquid, and then you see a clear gas come off. And I know it's hard to see a clear gas, but you can distinctly see some parts of it rising off of it, and it's a very, very cool demo. Something my teacher did for me when I was in school, but now we know it's not safe, so I can't do for you. But very cool nonetheless. And notice O2 is diatomic, so he got a 2, even though he doesn't have a 2 over there. Now, there are some special decomposition reactions. Okay, there's actually 4 of them. All right, and this involves, guess what? Polyatomic ions, because yay, they're the best. All right, so decomposition reactions of metal carbonates, okay, CO3 is going to produce the metal oxide plus carbon dioxide. So since carbonate looks like the most common gas that you know, CO2, take out the CO2 and then form the metal oxide. So CaCO3 breaks up into CaO, which, you know, is Ca2 plus and O2 minus together, and CO2. Okay, so that is your carbonate. Decomposition of a metal hydroxide, which is your base, yields the metal oxide plus water. Where have we seen this before? That's right, this is the opposite of the synthesis of a base. Okay, so CaOH is going to break up into CaO, and again, Ca2 plus, O2 minus, and H2O is made. So you can naturally guess that we are also going to break up our acids down here, which I forgot I put fourth. And then we'll go up and do the third one. So the decompositions of acids yield the nonmetal oxides plus water. So pull out the water and then have the nonmetal left, and with whatever oxygens are left as well. Okay, so again, this is opposite of what we had for the synthesis of our acids. And then the last one is our chlorates. So we have carbonates, we have chlorates, we have bases, and we have acids. All right, so those are the 4 special ones. So a chlorate is going to make a chloride and then the leftover oxygen. So basically take this CaCl, you're going to remove an O2, and then you're going to make whatever chlorides are left. Ca is a 2 plus, Cl is a 1 minus, so it's CaCl2, and then you would balance this out. You would put a 2 here, and 2 here, and a 3 here to balance all of that out. All right, so if you see one compound on the left, it's going to break down. It is going to divorce. Break the compound into their elements. Be mindful of who's diatomic, and be mindful of acids, bases, carbonates, and chlorates. Then balance your equation. Okay, so usually you'll see a heat or the electrolysis, but not always. All right, so let's try these out. So here we have KCl, and we're going to break that down. So what are the two elements that make up KCl? That would be K and Cl. And then ask yourself, are any of them diatomic? Are any of them Brinkelhoff? If you need, you can write those up in the corner and consult that every time. All right, so Cl is part of Brinkelhoff, so put a 2 there. Is it balanced now? Nope. So now I'm going to need a 2 here and a 2 here in order to balance it out, and then it is even. All right, Cu2O. Break it up into Cu and O. Anybody diatomic? Yep, oxygen is. So I'm going to put a 2 here. Is it balanced? The answer is no. So I have 2 here, so I'm going to put a 2 here. I have 2 here. Oh, wait, I need a 2 here. And then I need a 4 there. Now it is balanced. All right, CaCO3. Ooh, careful. This is one of my carbonates. So what do I pull out? What is the common substance that this looks like? That would be CO2. Okay, and then I have Ca2 plus, and then I have a remaining oxygen, O2 minus, so I have CaO. And then that, my friends, is already balanced. H2SO4. Is this an acid or a base? This is an acid. So pull out your water, H2O, and what's left? Okay, so I got rid of the H's. I got rid of one of the O's, so I have 3 left. So I have SO3 and H2O, and that is balanced. Good. SROH taken twice. This is a base. So pull out your water, and then it leaves your metal oxide. So Sr is a 2 plus in column 2, O is a 2 minus. We make SRO. Student Resource Officer. Am I balanced? Let's say Sr, Sr, O, but taken twice, O plus an O, and 2 H's. Yes, it is balanced. And then lastly, KClO3. This is our chlorate. So what does the chlorate become? The chlorate becomes a chloride plus oxygen. So K is a plus, Cl is a minus. I have KCl. Okay, am I balanced? Not quite. I have a 3 and a 2, so I can put my 3 here, my 2 here, and a 2 here, or I can do KClO3 makes KCl plus 1.5 O2s, and then that works out to be balanced as well. So again, if you can't read my lovely penmanship, take some time, push pause, try them, but you'll see that I walk you through the special reactions down at the bottom. You have your carbonates, which make your metal oxide and CO2. Your acids make water and your nonmetal. Your base makes water and your metal. And your chlorates make your chlorides and oxygen. Okay? Don't forget all about Brinkelhoff, because if any of these guys are diatomic, you need to show that. All right, so that is decomposition, aka the divorces.